So now I should talk about CERN and an anti-miracle. I have written here LHC, but LHC is just the biggest machine and the most important machine at this institution CERN in Geneva, which is paid by taxpayers of many European countries. So among which Denmark, for instance. And this CERN has just got this machine working essentially last week. We were celebrating by champagne and so that this machine had now come up to really work with 3 TeV. And now I owe you to tell TeV, that's sort of a mosquito energy. So it's very small, but it's very big on the scale of a single proton, of which we have 6 times 10 to the 23 in 1 gram. That's very, very much if you give that energy that is comparable to a mosquito. So it's an enormously big energy for that. And this is a record. And now the machine is working. And it is very great things, because the theoretical and experimental high energy physicists have been waiting and waiting for years to get the machine work. And I think somehow theoreticians have worked into more and more speculative things, because we have lacked experiments, because there has been a very long time before this machine has come up. And this is a little bit due to that we think that there is a kind of God against it. And that is a theory of Masao Ninomiya and myself. And that is what has to do with this concept of anti-miracle. We want to say that machines which produce a particle called Higgs, which is to be produced by LHC. So far, I don't think it produced any. But that will come. That will come. At least one didn't see it. One didn't see any produced Higgses at all. Also not by a smaller machine, which probably has produced about 10,000 or so. But we really don't know, because we didn't see any. So, yeah, we can put this. Yeah, so I am, this machine is called Large Hadron Collider. And large, of course, is just big, and collider means that you collide things against each other. And hadron is a somewhat screwed notation for the proton which is shooted. You should know that we are made from, we are made from protons and electrons and so on. I think you know what we are made from, but to be completely safe, yeah, you can see we are made from cells and so on, but don't forget about that. Then we are made from atoms. And here is sort of a symbolic drawing, which is in a way the picture by Niels Bohr of the atom. And inside the middle, in the middle of the atom, there is the nucleus, and that consists of protons and neutrons, so-called nucleons. And around it goes the electrons. And they are going in such orbits. But I think according to modern quantum mechanics, they are in mysterious way different places around the atom at the same time. But that we don't have to think so much about in the first go. That is quantum mechanics. Now at least you have heard the word quantum mechanics, which is what the theory which we are working on all the time. So in a way we should know that, but I think I will try to escape it in a relatively short talk. But you should have in mind that we have this mysterious theory that the creators of the theory didn't like it and complained about it. For instance, Einstein had very famous complaints. But then we have this nucleus, and it consists of these so-called nucleons, neutron and proton, which are called with a common name nucleons. And that is, so to speak, a class of particles consisting of proton and neutron. But then there is a bigger class of particles that is called hadrons. And that contains the neutrons and the protons and a lot of other particles, which I already told you. There are some called pions, there are some called, what? Yeah, that's for instance written here. Yes. There are written some names of hadrons, this class of particles. There's, as you can see, the proton, there's a neutron, there's a pi minus, pi plus, pi 0, k meson, k minus, k 0, lambda, blah, 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 blah. There are so many that we have a whole little book about them. And these particles are actually produced in collisions of, for instance, protons. Then you produce a lot of hadrons, and the proton is itself a hadron, and you also produce sometimes protons, as you can see, if you collide protons on protons. And very seldomly, you produce other particles than hadrons. And now, since I'm saying hadron is a class, I have to tell you that there is at least one particle which you should know, because I mentioned the electron going around in the atom, which is not a hadron. So electron is not a hadron, but pions, kaons, proton, neutron are hadrons. And now one calls it that one is shooting hadrons, but it is in a way a little bit strange, because this is like I would say, I am talking to mammals, because there are lots of mammals here listening, but you are all from the same type. In the same way you shoot these protons, and it is all protons in the Hadron Collider, but they are of course hadrons, because that's also the proton. So, but it is to make sure that it is not the electron, because one had another machine, electron-positron collider, which collided electrons, and that is another type of machine. So this is different. Anyway, so this is the hadrons. And then I should talk about this antimiracle. And the antimiracle, which I think is the best antimiracle, the most mysterious happening, which could be like seeing a miracle, like seeing Jesus go on the water or so. That is that there was another Hadron Collider machine. And this machine was called SSC. And it doesn't really matter what this SSC was, but since I'm now mentioning it, I should say that it is meaning superconducting super collider. So this SSC means superconducting super collider. Superconducting super collider. And that is because these machines use superconducting, they have the current running in superconducting, and then it was very big, and it was therefore a super collider. In a way, it was too big, because that should have had, that should be a very big ring.